So good afternoon. Today we will be discussing again the speed governing system. So as we have already gone through the diagram of speed governing system, I am again discussing this how this will be working. For understanding this system, you have to know that point C is fixed. So this point is a fixed point. It cannot move. So point C is a fixed point. It cannot move. So it will be always on the same position. Now you understand we have this speed changer. This will be to set the speed governor at a particular speed. And then this point B is dynamic and it will be sensing the actual speed of the turbine and generator, and on the basis of this point will be moving up and down. So now this point B will be going up or down. So first I am considering that this point we have set this A point to raise the speed of the generator. That means this A point will be moved downwards. And due to this movement, and as B is directly connected to this point will also move downwards. Now when this A point move downwards and B point move downwards, this D point will move upwards. So this D point will move upward, and due to this movement of D point, D's point will also move upward. And because oil is filled in this point, it will be going from upside in this piston. So this main piston will be moved downwards, and due to this E point will be moving downwards, and this valve is also open, and steam, this turbine will increase, and due to this increase in the steam in the turbine speed increase, and due to this speed increase in the speed, your frequency will also increase. So this is how when we will be working. Now consider that this A point has been fixed for a particular reference speed. So this has been fixed at reference speed. So it is fixed at reference speed. Now we have sensed that the speed of the generator, or that means frequency of the system, has reduced. And due to this reduce in the speed, this point B will again move downwards, and then again this D point will move upward, and due to this E point will move downwards, and speed of this turbine will increase. Now if it is detected that the load has been reduced, that means frequency has increased, and due to this E point will be moving upward, and due to this movement of this B point upward, this D point will be moving downward. Due to this movement of this D in the downward direction, these 2 points will move downwards. And due to this movement in the downward direction, oil will be flowing from downside towards main piston. That means this main piston will be shifted upward. That means this point E will be moved upward, and due to this movement in upward direction, this will be closed, and due to this the turbine steam input will reduce, and it will reduce the frequency or speed of the generator and turbine. So this is how this system will be working, and speed governor will be working in the system. Any confusion to anyone? Generally, a theoretical question can come in the examination to explain the speed governing system operation. So you have to explain the operation of this system completely, that how this system will be working. So no student have any confusion. So now I will be moving forward. Now we will be discussing parts of this in detail. As we already gone through that first part, which is associated with this speed governing system, is speed governor. As we have discussed, this is a fly ball type speed governor, and it is the main part of the system, because your complete system functioning will be depending on this fly ball speed governor. And when with the increase in frequency or speed, balls will move outward and be move downward. This is this part. And this is point B. So this will be rotating. When the speed will increase, these 2 points will be moving outwards. So this both points will be moving outwards. That means this point B will be moving downwards. So this is how this fly ball speed governor will be functioning. And if the speed or frequency reduce, then these 2 points will be moving inside. And when these points will move inside, these 2 points or B point will be moving upside. So this is when this is moving outside, B point will move downwards, and when these points will move inside, B point will move upward. So this is how the speed governor will be functioning. Now then second part is linkage mechanism. The linkage mechanism is A, B, C and C, D, E. This is your linkage mechanism. Out of this, C is a fixed point. C is fixed point and it cannot move. D point will be moved on the basis of B and A. A and B point, according to this, your D point will be moving and your E point will be moving on the basis of D point. As we discussed, when B or A move upward, D will move downward. And if B or A move downwards, then D will move upward. So this is how this D point will be moving. And with the help of your amplifier, when D will be moving downwards, your E point will be moving upward. And when your D point will be moving upward, your E point will be moving downward. So this is how this linkage mechanism will be working in the system. Then third part is your hydraulic amplifier. So as we have discussed, it has two main part. One is main piston. Second is your pilot valves. And we can say third part, which is your high pressure oil. So this hydraulic amplifier will be consisting of main piston, pilot valves, and high pressure oil. And this will be the function of this hydraulic amplifier is to convert low pressure or low power level to high power level. And this hydraulic amplifier will consisting of so this will be your hydraulic amplifier, which will be consisting, these two are your pilot valves, and this is your main piston, and its functioning is when this D point will move downwards, these points will move downwards and oil will flow from downward side and E will move upward. And this movement, E movement, will be at a high pressure, and this D movement is at a low pressure. So this is your hydraulic amplifier. Then we have fourth, which is speed changer. So this speed changer, as we have already, it is to select the reference speed, and this downwards movement will be to increase the speed, and upward movement is decrease the speed. So when we moving, and this will be this part. This will be setting the synchronous speed of generator. At which synchronous speed we want to work our generator, that will be decided by this speed changer. So these are the 4 parts of your speed governor system. Now we want to model these governing system. So we have model of speed governing system. Now we have to convert these all part into its equivalent mathematical equations, and then on the basis of that mathematical equations we will be getting the transfer function of this complete system. So for getting the model of the speed governing system, we will be considering one part one by one at a time, and then model that part, and then on the basis of that we will be finding the transfer function of the complete system. So we will be considering the steady state condition of the system, and we are assuming that the linkage mechanism is stationary. That means it is fixed and there is no movement in the system. And your pilot valves are closed. Your steam valves is opened at constant magnitude. And your turbine and generator are working at constant speed. So these are the steady state condition for this system. That means there is no movement. There is no movement of pilot valves. There is no movement of steam valves. And then your turbine and generators are working at a specified speed or constant speed. So for this, we will be getting that your F naught is your system frequency. That means indirectly it is your system speed. Then we have PG naught, that is your generator output. Or indirectly we are saying that it is your turbine output also. That means we are neglecting the losses. That means your generator output and turbine output is fixed. And then we are saying that we have XE0. That is your steam valve setting. So these are your some of the specified terms which we have considered. Now let point A moved downward by small position delta x A. That means we have moved the A or speed changer position by a very small amount, that is delta x A. And due to this command, the turbine power output will be changed. So your turbine power output is changed by delta PC. That means, and we know that your delta XA will be directly proportional to your delta PC. That means your delta XA will become K1 delta PC. Now, due to movement of A, there will be movement in point C and D, and they are denoted by delta XC and delta XD. And due to this movement delta XD, there will be movement of high pressure oil in the hydraulic amplifier, and oil will be moving in the top of the main piston, and that means the stem valve will move downwards with a distance delta XE. So that means your valve position will be moving in delta XE, and that will increase the turbine torque, and hence your power output delta PG will also increase. So this is how your system will be working, as we have already discussed. Just I have given them a mathematical term for each of the term. Delta XA due to delta PC, then that will be moving, changing the position of a D, then it will be moving the position of E, and that means your generator output will be also changed, and that means the frequency of the system will also change. So this is basic terms which are related to this term. Now with the increase in speed, frequency will be also increased. So we are saying that this increase is a very small amount, that is delta F. And then this, due to this movement of delta F, point B move downwards by amount delta XB, and this delta XB will be proportional to delta F, as we all know. And we assume that the movement are positive if the point move downwards. So we are saying that if point B move downwards, then it will be plus, else it will be minus. And since we are considering very small change in the system, so it will be considered as a linear system. So we are considering that all the relationships are linear. All the relationships in the system are linear. Now we have two factors contribute to movement of C. The first factor, which is movement of B, and second is movement of A. So we have movement of B will be causing movement in C, and then movement of A will be also changing the position of C. So that means we have two factors which is affecting the position of C. First is movement of B. So increase in frequency move B point by delta XB, and it will be lower, means move downwards, and this will be considered as positive movement, and we can say that it will be K1 into delta F. Delta XB will be K1 into delta F. And then there will be movement of B, that means movement of speed changer. So this will be when we lower the speed changer by delta XA, it will lift the point C upward by an amount that is proportional to delta XA. So we are saying that delta, it will be delta XA. We will saying that the K2 dash, that is delta or it we can say it is directly proportional to delta PC, that is your control signal. That means total movement of XC will be K1 delta F minus K2 delta PC. So this will be your movement in position C. Now we have two constants K1 and K2, and they are dependent on length of arms L1, L2, L3 and L4. So it will be depending on arm AB, that is L1, and it will be depending on arm BC, that is L2. If you go through this diagram, AB is L1, BC is L2. So it will be depending on L1 and L2. Now the moment of D will be contributed by movement of C and movement of E. And because they are both are moving downward, when D move upward, as we already discussed. When D will be moving upward, E will be moving downwards, and when D will be moving downwards, E will be moving upward. That means your delta XD will be K3 into delta XC plus K4 into delta XE. And this K3 and K4, your K3 and K4 will be depending on CD and DE, that means L3 and L4. Now we have to find the equation of this hydraulic amplifier. So we are saying that oil flow into hydraulic cylinder is proportional to delta XD. As we discussed, movement in XD will be changing the oil flow in the hydraulic cylinder. That means this will be decided on the basis this is proportional to delta XD. That means your change, that is delta XE, will be K5 integration 0 to T minus delta XD dt. This is integration because it is the movement of your oil. The amount of oil which will be flowing in the system, it will be decided by delta XD minus, because it is opposite. So this will be your, and your constant K5 will be depending on your fluid pressure and cylinder properties. That means length, dimension and all other terms. So this will be your delta XE. So when we take Laplace transform of all these equations, so that will your delta XC will be K1 delta F minus K2 delta PC. Delta XD will be K3 delta XC plus K4 delta XE, and then delta XE will be minus K5 upon S delta XD. So these are your three equations. When we take Laplace of this, these will be your linear terms. So there will be no S. This is integration, so it is 1 by S. So it is minus K5 upon S into delta E. So your delta XE will become K2, K3 delta PC minus K1 K3 delta F divided by K4 plus S upon K5, and we solve it and we say that it is Kg upon 1 plus STg delta Pc minus 1 upon R delta F. R will be K2 upon K1, Kg will be K2, K3 upon K4, and Tg will be 1 upon K4 and K5. So this will be your delta Xe term. So this is represented by this. So now in the next class we will draw the block diagram for this delta Xe. It will be simply